So yes, our team is called AK0, Architettura Kilometro Zero, which means 0 kilometer architecture, because it reflects a little bit our idea of trying to source the material, so that the hard stuff for building from as close as possible, but implemented with knowledge from all over the world. So that's also a reason to be here with all of you, to exchange knowledge with all of you. I would try to, this morning, to give a small introduction to explain better how we work, and then I show a couple of recent projects. I normally like to start from this, because it's the number of people we are at the moment on Earth, the figures from the day before yesterday. And so what I always say is, we can't build, if our goal is to provide shelter for all those people, and we are rising and rising, we need to do it with natural materials. There's no alternative. So we have to know about natural materials, and we have to implement this for sure. And the good thing is that a lot of people in the world already build with natural materials, but we could perhaps argue if this little house that I took in this picture is a house for a young couple in Côte d'Ivoire. They just started to build it with a wattle and dowel technique, and we can argue if this is an appropriate shelter or if it will be an appropriate shelter. Perhaps we could help to implement something and to make it better, but at least it is for sure a low impact building. This is from an environmental point of view, except for the plastic membrane on the roof. Okay, natural materials are entered also the contemporary debate in architecture. We have fabulous bamboo architecture in Southeast Asia, and of course in Colombia. I know that there are some Colombians here. I didn't put pictures of that. We have straw bale architecture, contemporary. I won't talk about that because Paulo will do it after me, so he knows better. And also raw earth. We have big names like Herzog and de Meuron working with raw earth in meanwhile, and doing quite huge industrial buildings, or like this one in Germany, the A02 campus in Darmstadt, almost finished. And raw earth goes also as building material to the Biennale di Venezia, so this is Martin Rauch and Anna Hellinger, so we can really state that it entered the debate. But does it really touch all those people that I showed at the beginning? Probably not. So this kind of architecture is done by a very small group of people for a very small group of people. So how can we do to spread this way? Of course, I have no answers to that question, but we have small attempts that we do with our association, and I would like to show you. But first, this I think I can go quick, because the reasons for building with other reasons for building with natural materials are very clear to you. A low gray energy impact, with the same amount of energy that you use for a wall that is 3 meters long in concrete, you can build a 200-meter long wall with rammed earth, for example. And we're talking about mechanized rammed earth. So if it would be manual, even longer. Then you can have a pleasant inner climate, and for the properties of raw earth as a building material, for its capacity of absorbing humidity, you know that. I know. You can use raw earth to implement the energetic behavior of buildings, like we did in this refurbishment in cooperation with AK0. This was in L'Aquila, the museum. And raw earth is non-toxic. This is a very important point for us, because being sure that you can touch raw earth mixes with your hands without risking anything, or with your feet in this case, makes it very easy to implement educational activities, where you, of course, have still to care about safety issues, but much less than on a conventional building sites. And so our approach is a bit this. We try to use the building site as an exchange hub, directly the building site, where we try to make education, research and practice meet. A little bit what the friends from Pilico just explained, so that all these spheres need to come together. We are convinced that doing it directly on site is a good option, at least based on our experience. Of course, there's nothing new in it. Learning by building is an issue that this book by Carpenter is from the 90s, and even earlier, Peter Hübner, for example, built student hostels at the University of Stuttgart in the 80s already, involving the students directly in designing and building, realizing the construction. The thing about learning by doing directly means, from an educational point of view, that you can, for example, learn about the sequentiality of building steps. You understand directly what needs to be done first, what can come later, things like that. You can guess very easily about potential of materials. You can see what can be done with the material available and what cannot be done. And what can be done if we are alone, if we work with our competencies, and what can be done if we have the opportunity to involve larger competencies, experts. And of course, this also makes it much easier to make theoretical contents spread. In this picture you see a collaborator explaining the production of lime, the cycles of lime production, which is not so easy to guess. It has some chemical notions in it, but once you did it on the building site and then he explains it to you, it's much easier to know about. This was our very first experimental building site that we did in 2009 in the Abruzzo region, Casale Incontrada, and we did it with a water-and-out technique, quincha, that we learned in Peru on the Andes, where this is a common building method, especially for those areas that have a stronger seismic problem, because it's a light construction, so it is foreseen in the local regulations, building regulations, the national building regulation in Peru. So this was interesting for us because we were building in a region where a few months earlier happened a very bad earthquake in L'Aquila in 2009, you know, probably. Then other projects followed, where we had other people on staff and other experiments with ground earth, with students from the Rome University. This is close to here, together with Pilico. And so the interesting thing about doing design and build workshops with many participants is that the design process is quite different from what we do normally in our offices or in our conventional practice. Because you're normally asked to design something, then you develop a couple of alternatives, you show it to the client, and then you decide, and that must be built because there's no time to go on it again. So it's very linear as a process. If you have committed people on site, you can afford to do this process several times. So you have feedback effects that are very interesting. You have even very small suggestions that arrive at a certain moment, and you say, why don't we do it that way? You say, yeah, actually, why don't we do it that way? It's much better, and so that helps. And it's with this philosophy that in 2011-12 we started a project in Guatemala where we were asked to build a little school building. And before going to Guatemala, we used the opportunity of another workshop with Roma Tre University in southern Italy to test the building process, exactly for the reason I was just telling. So for 1 week, the workshop was hosted in a touristic resort in Calabria, in southern Italy. So it was also very relaxing, but we worked hard for all the days, and so we had to test what it means to build round earth walls with people that never did it before, and kincha panels and some timber building constructions. And with this knowledge, we then went to Peru. This is to Guatemala. Sorry, this is my colleague Laura, who was in charge of directing the building site in Guatemala. Here, explaining the work to these are the teachers in the school that we were building at the time. I show you quickly some images of it because this is an old project. Some of you might already know it. I already presented it here. Inside, around earth, protected with a lime render. Those parts where it is supposed to get wet, because it's the kitchen here. Because it is a school, a professional school for bakers. And here we have another example of this effect of people being on place and then actually changing the design, but in a good way, improving it while doing it with consciousness. And this can also be explained what happens when a large group works together and is very committed, of course, and is very interconnected. They speak the same language, let's say. It's an example from another field, from another realm that explains that very well what can happen in these cases. These are screenshots from a simulation done by Mitch Resnick, which is a teacher in mathematics at the MIT, and he always gives in his programming classes, he gives very simple problems, phenomena, to simulate with a script. That's the task the students have. And what they did here is simulated how ants find their food. So this is just it's the screenshots from software, but it simulates the behavior. So this is the food source, and this is the colony of ants. So what they do, they just start looking for food in all directions. At a certain point, somebody finds some food and says, "Hey guys, here's the food, come with me." And then this trail here gets stronger and stronger until the food is over, and then the process starts again. But this is an emerging effect that says that you can explore unfamiliarity. You can just do it, start, and you will find something. If you have the conditions I said before, if you are well interconnected, you can communicate, and you are committed to it. And you have redundancy, because you need many people, which is actually the enemy of classical engineering. Normally, it's if we talk about redundancy, we say, "Oh no, that means that we have something we don't really need." It's not true. There are a lot of examples in nature where we have redundancy. For example, our taste buds that we have on our tongue to smell and to feel tastes when we eat. There are some 15 million, I think. And they need to be so many because according to where the drop of food drops, they reconstruct the information we need to say it's tasty or it's not good or it's good. So they need to be so many. And was another picture? No, I didn't do it. The same happens with this. This is a bamboo column at the microscope. So in classical engineering terms, we could say that the best way of having a pipe is to have all the material as far homogeneous and as far as possible from the center, because this is the best way it works in terms of inertia. Why doesn't bamboo grow like that then? Why does it have all these bubbles? This is because bamboo can react to different environmental conditions. If the wind changes, I have smaller pipes that can become stronger than the ones on the other side, and they can interchange. But this only works because they're strongly interconnected and they're a lot. So, of course, I also needed this as a... And this is because in Italy we started considering it a natural, local material. This might perhaps comes as a surprise because, of course, bamboo is not native in Italy. But I had a map on that, but it doesn't matter. Bamboo grows very well between 46 degrees of latitude, north and south. So it has been imported to Italy and it grows very well. There are a lot of bamboo plantations. It's therefore that we consider it a natural material, a local material in Italy, and so we started to do some experiments on that. And the good thing is that it is a very flexible material, which makes it very easy to interact directly with it. So this manual interaction helps to pass a lot of information. In some way, we can say that the bamboo already knows what it wants, how the shape it wants to assume. And this helps the design process and the building process, especially if people with no previous experience are on place. These are pictures I took from a publication from by Otto, the German architect, and this confirms it a little bit. A curve is an intelligent, better informed line. It's not only the connection. But it was very easy to build. It was the paints, how high this is, but it's actually the material who decided. And so we managed to build this dome. Then we replicated it with other shapes and other experiences. This is a workshop in Sardinia. This is again in Abruzzo, where this is with whole bamboos from Italy, from Tuscany. And with this expertise, we dared to go to Côte d'Ivoire this year, where we are planning to build also a little building. So in the very start, we spent a few days there to understand what kind of materials they have. They have, of course, a lot of raw earth that you see. They usually build in raw earth in the villages, but they also have bamboo, which they cut for us, and so we could start. Of course, the bamboo is very different from the one we have in Italy. It's much stronger, much bigger, which caused some problems because the tools are not very suitable. So we had to build new tools, which was fortunately not a problem because we find people who could do it in very quick time one morning, and the problem was solved. We had new tools. And then we built it, and it's a bit a confirmation for me that it was able to build with people that have nothing to do with architecture. Because the people you see here in the picture are mainly beekeepers. They are from an association that is spreading beekeeping in northern Côte d'Ivoire. And they were here for their annual training. And since the same association is now planning to start parallelly to the beekeeping program, sustainable architecture program, they have been involved, forced, I would say, to build this little experiment with us. But they were enthusiastic about it, and it worked really well. Then just a little roof, because we had only a few days, and the main purpose was really to understand the conditions to make a project, I hope, for next year. So then the roof was carried, first by hand, and then by pickup, to a plot where they have a training vegetable garden, crop garden, which is also the area where we are supposed to do a small building. But it's all to be done yet. This is only a small experiment. The other experience I would like to present to you is what we are doing with BION. BION stands for Building Impact Zero Network. It's a network of 7 associations from, not only associations, we have also university institutions in it. And we are from 5 different countries, Italy, Spain, Portugal, Belgium, and Sweden. And we launched with this network the training program called Learn BION, which includes workshop in all these countries. I can show you some images. For example, in Portugal, we did a workshop on BTC, compressed earth blocks, where the result of the workshop was this little artist's residence. Then the Swedish guys suggested the technique of kubus, cordwood, where chucked wood is used as bricks with an earth mortar. Here you see they built this selling facility for an organic farm close to Stockholm. Then Cagnaviva, participated with this event roof in a place owned by the University of Barcelona. So a place to have lessons, open air lessons and things like that. And this is still under construction because it was now in April, the Round Earth building in Extremadura, done by our partners AK0, and we were also a bit involved in this workshop. And in this network, we decided to work in Casa Prota, which is a small town 60 kilometers northeast from Rome, where Renato Vivaldi lives. He lives here, and who helped us very much to implement this project. What we did here is to graft a building made of natural materials in this very unnatural precedent. This is a building from the early 80s that was never finished and stands empty since 40 years at the very entrance of the village by the town, by the way, which is not really nice. So we suggested to the municipality that we could use it better, and with the budget and the time we had for a 1 month workshop, the suggestion was to graft a little pavilion in it, just to start. So the idea is of having this place as a closed building that we can also heat it for smaller activities and use it in winter time. And also another thing that we were very interested in is to assess the energetic behavior of the walls that we would build in raw earth. And for the rest, we just make a safety fence all around, and so this place can be used for activities and so on. And so this is one picture of the almost finished grafting with light earth walls and quincha walls, Volendau walls, rendered. And on this, perhaps I can show you a little video.
Attention, sir.
These were some suggestions we made to the local community how to use this.
Normalmente i workshop come questo hanno un rapporto diretto con il nuovo.
Really local material on the hill, 50 meters constantly sized.
sta dentro il muro abbia più facilità in uscita.
Little time left because I have a very small thing to show more. If there's time. Okay, so the place in Casa Prada that you saw that we equipped as a building site was meant to be a building site for 1 month and then to start another activity. At the end, for the moment, we decided to keep it as a building site because the experience was interesting to have people on place learning about building with natural materials. And so we went ahead with that. We had 2 other workshops already, and we're planning to do more. So this banner here with saying Cantiere Scuola, educational building site, is still there, and so we are open to do new experiences on that. I wanted just to tell a few more words on the technique, because as I said, it is the Quincha technique that we learned from the Peruvian Andes, so from a rather chilly region. But surprisingly, what they don't care so much about on the Andes is thermal insulation, which we have to care about, otherwise we can't cope with the regulations that we have. So this is actually the only little innovation that we added to the building system. That you see that you already saw it in the movie. Some pictures. So this is actually the only little innovation we added, is that we doubled the layer of Quincha frames. So we have 2 layers with an insulation layer in between. In this case, we used these wood fibers as panels, but we also tested other solutions with straw and light straw, of course with a vapor barrier. And then a second layer outside, which holds the final render. We made also some calculation, but we still don't have real measurements. We're waiting for that. This is the second technique we used, light straw. I don't need to explain so much about this to you, I think. Okay, you already saw these pictures. And this was a small additional experiment. So we said to ourselves, if it's possible to start from a prefabrication process where you first build timber frames, then you fill them with canes, and only at the very end you clad them with mud. then why not introducing a higher degree of complexity? Is it possible? And so we partnered for this with a small timber building company that helped us to prefabricate timber frames with another shape. We call it quincha diamantata because the shape is like the faces of a diamond. And so the interesting thing about this, what we were interested in, is that the company prepared the frames, the elements for us, cutting all the joints with numerically controlled and all this stuff. But then, once we had this on place, it was very easy, even with untrained persons, to assemble everything in 3 hours. We had the whole wall on place exactly as we wanted it. So here, this is one, if we ask the same question, what next? This is something we would like to investigate a little bit more, to how this prefabrication, where can we arrive with prefabrication for natural materials. So this is a first little attempt in this direction. And this is another one, it's the very last. This is a fixed furniture we designed as an addition to the small library that I showed you in Valverde de Burgos in Extremadura in Spain. And what we did here is an inverted printing process, we could say. It's not really a printing process, but we designed an organic shape that we wanted a little bit as a seating landscape. This was the idea behind. And to do that, we had a person helping us with grasshoppers. I know that some of you also use the same software. To get out with a map like that provided these molds. These are the negative molds we used to shape the upper part of the cylinders, which is then the fact that makes it all homogeneous, the surface. It's the way we could control the surface. Then the procedure, you can see here. This is the mold, the plywood mold, which was already filled with mud to be stronger. Then a small plastic membrane as a division, separation layer. And here we did the real rammed earth, which could then be upside down and provide these seats with a shape and this bench, this seating landscape. So this is another small project where we're trying to bring together digital fabrication with natural materials. So this is just to say that this is one of the fields we are researching into. So I conclude with this one. Thank you for your